Morning, how are you?
Good, good. Well, thanks for having me on. I'm a big fan.
Oh, well, thank you. I mean, I was aware of you, obviously, beforehand and aware of your work, and you reached out to me, and obviously I was really happy that you got in touch because you're somebody I wanted to talk to. I try with the show to, if there was a particularly testing subject, I do try to listen to both sides, not maybe always give weight to both sides. I also heard your interview on Joe Rogan, which I thought was particularly great. The entire audience might not know you. I will refer them to the Rogan show. We'll put it in the show notes and suggest they go and maybe listen to that after this one. But do you want to just give an introduction to everyone? Let them know who you are, the work you do, and I think they'll understand the topic we're going to get into.
So I'm a climate scientist who works in the Department of Atmospheric Sciences at Texas A&M. I spent really the last 20 years working on the physics of the atmosphere, things like water vapor feedback and cloud feedbacks and climate sensitivity and things like that. And then really in the last year or two, I've decided that that's actually a solved problem. And I've been kind of looking at it and saying, well, what's the big problem for humanity? And it's really energy. I mean, energy is the most important thing that we have. We need lots of energy. Lots of people live in poverty today. They need more energy. And so how are we going to get that without baking the climate system? And so I've really started thinking a lot and doing research on various energy issues. I've been looking at the Texas grid, for example. And so, that's what I like to talk about. And hopefully we'll talk about climate and energy here.
Well, obviously this is a Bitcoin show, and I might get into that towards the end with you. But even though it is a Bitcoin show, we do cover other subjects and things that may be asymmetric to what we do. But it's funny you mentioned the Texas grid, ERCOT. Are you aware of the work being done with Bitcoin miners working with the grid?
I am aware of a little bit of it, but I can't say that I know a huge amount of what Bitcoin is doing. But I know there are Bitcoin miners that have long-term contracts with providers, and they sell power back to the grid at times of high prices. And I guess they also agree to cut down their mining when the supply is tight and stuff like that.
Yeah, so what they do is they buy the excess energy, and then what they can do is they can switch off at a click of a finger if there's a need for increased demand in the network. There's some great people that next time maybe I'm in Texas, I'll bring you along and you can meet them. They have a meetup on the mining, and it would be a great thing to discuss with you. But we're here obviously to discuss climate change, and just as a setup, it is relevant to people in the world of Bitcoin in that Bitcoin miners use energy. Some people consider a lot of energy. I think on the grand scale of all energy consumption, it's quite small, but it's growing. And it's certainly been a topic which the mainstream media has reported on, sometimes incorrectly, and also aware that certain regulators have particular issues. It's coming up in the European Parliament. New York State has now banned Bitcoin mining with fossil fuels. So it's certainly a subject that's relevant to me as a Bitcoiner, but just me as a human as well. I've historically been concerned about climate change, and sadly, I'm also a hypocrite. I fly a lot and own a car, and I share the concerns other people have, and I haven't really dealt with things personally on a level I should, but we can come back to that. At the same time, I did an interview with Alex Epstein. He was requested by a number of people to come on the show. I also have Michael Schellenberger's book, and I will interview him at some point. With Alex, I was initially very skeptical, read a lot of reviews of his work, and I also watched your debate with him. I'm still skeptical of a lot of the things he says and his approach to picking his arguments, but he did make me reconsider the energy mix, what can go wrong, especially right now as we're in a time of what we would call an energy crisis, and what the impact of that is. We have particular issues with in the UK with a range of things, from people in fuel poverty and can't heat their homes, to swimming pools having to close down because they can't afford to heat the pools, to the impact that has on the supply chain because the higher energy costs has on logistics. So there's a range of issues related to that. So I would say he made me more aware of that. But then you reached out to me, you heard the show, and you wanted to come on and counter some of his points. So there's kind of my setup. Do you want to explain why you reached out to me?
Well, sure. I mean, I heard the debate, and I heard you all talk about my debate, or he mentioned me on the debate. And so I thought, well, that's my entree to email you to say, hey, have me on. So I think it's important to understand that Mr. Epstein and I agree on a lot of things. So we don't disagree on climate change, for example. When we debated in Steamboat Springs, there's really no disagreement on whether climate change is happening, whether humans are responsible. The disagreements come on what do we do about it. And my perspective is that climate change is a very serious threat, and that we're predicting warmings for the next century of, say, 3 degrees Celsius, about 5 degrees Fahrenheit. And to give you, most people look at it and they say, who cares? Why do I care about a few degrees Celsius or a few degrees Fahrenheit? What is your audience? Should I do Celsius or Fahrenheit or both?
I mean, think both, because it's
okay.
Certainly half is in the US.
Right.
I'm UK. I understand Celsius.
Yeah. Well, let me put it this way. If I only give Celsius, because I think in Celsius, just multiply by 2 to get Fahrenheit. That for temperature changes, it's just a factor of 2. You don't have to add the 32.
Okay.
So for 3 degrees Celsius, people say, who cares? And the answer is, let me ask you a question. How much colder we're talking global averages here, not local temperatures, global average. How much colder do you think the last ice age was?
I wouldn't know, but you tell me.
Right. So it was about 5 degrees Celsius or 10 degrees Fahrenheit colder. So if you think about that for a moment, if in the global average, if you cool the planet by 5 or 6 degrees Celsius, you get an ice age. You get sea levels 300 feet lower. You have ice, thousands of feet of ice over the Midwest. And it's a different planet. If you walked outside your front door, the world would look completely different. And so we're talking about warming over this century of a few degrees Celsius, 3 degrees Celsius. That's 60% of an ice age of warming. And now it's in the opposite direction. Obviously, we're warming, not cooling towards an ice age, but still, 3 degrees of warming is an enormous amount of global average warming. It would remake the face of the planet. And my concern is that nobody has any idea how much that's going to cost to deal with. And I worry that my kids, I have 2 17-year-olds, and I expect them to live through most of this century. And my concern is that by the time they're old, they're going to be spending all of their wealth just trying to stay alive, building seawalls, building freshwater infrastructure, paying to relocate people, installing air conditioners. It's going to be immensely expensive to adapt to all of these changes. And so I think that's a significant threat. And so then you get to the question, okay, so this is this threat. Imagine all we had was fossil fuels. That was the only energy source. Well, I would say, okay, we got to keep burning them because we need energy, and we can't stop energy. But there's this alternative source of energy that doesn't change the climate, renewable energy. And so then the question becomes, well, can we replace fossil fuels with renewable energy? The answer is yes. And hopefully we can talk about that at some detail. But a lot of what you hear in the debate about building a grid with renewable energy is wrong. And I'm sure, as Bitcoin people, you hear lots of people say stuff that's just, wrong. They can just Google it and find out it's wrong. And I'll say something on a show like this. I'll say, wind and solar, we can build a grid with them. And, people just say, well, that's bullshit. And I'll say, well, here's some studies that show it. And that's the end of the debate. They don't engage you on the facts. They just refuse to accept that we can build a grid that's reliable, that's mainly wind and solar, maybe 100%, not mainly wind and solar, maybe 100% climate safe, carbon free. And so we can avoid the impact of climate change, and we can avoid this risk. And in addition to avoiding that risk, you also avoid millions of deaths from air pollution every year. You avoid, what we're going through right now. So let's talk a little bit about high energy prices, because I think that's something that you mentioned and is really interesting.
Well, we'll just come back to high energy prices first. I just want to have one question on the potential change. I've obviously followed the target that want to, there's like this general target to keep it, I think it's under 2 degrees.
Right.
But there is a range, and some of the predictions of the models range between, say, 2 and 5 degrees. Whilst Alex maybe disagrees that carbon has an impact on the change in the temperatures, as I see it, when I interviewed Catherine, and I assume yourself, there is a general accepted consensus in the scientific community that an increase in carbon increases the temperature. What I want to know is, Alex mentioned the S-curve. Is there is there like a maximum temperature we hit if there was continual burning of fossil fuels?
No, I mean, not at any level that we would care about. I mean, in theory, if you warm the planet enough that you boil off the oceans, the temperature wouldn't get any higher. But there's no, I mean, as long as we're adding carbon to the atmosphere, the temperature is going to keep going up on any time scale, on any kind of scales that we care about.
So the S curve, that's not true.
I think what he's probably referring to is the fact that it's logarithmic, which means that and this is why when climate scientists talk about what we call climate sensitivity, it's always in terms of doubled carbon dioxide. It's that every doubling gives you the same amount of warming. So per part per million or per gigaton, as you add carbon to the atmosphere, each ton gives you less and less warming. So that's, I think, what he's referring to. It's not an S curve. It's a logarithmic curve.
Okay, so let's talk about the current crisis, as you mentioned there.
Oh, energy.
Yeah.
Yes. Okay. So I guess I have two thoughts about this. So the first one is that for any commodity crisis, which is basically what this is, I mean, energy is a commodity. You can always look at the event and you can say, well, here are the factors that contributed to it. There's the war in Ukraine. We're coming out of COVID. Governments pumped a huge amount of money into the economy during COVID to keep it afloat. Now all that pent-up demand is coming out. In the 2010s, a lot of drillers lost a lot of money investing in shale. They don't want to do that anymore, so there's less investment going on. And so you can come up with these micro reasons for this particular event. But the key thing to understand is energy is a commodity. If you look back at the last 50 years, you see the price of oil gyrating. It goes up, it crashes, it goes up, it crashes. That's just a commodity. That's what commodities do. Bitcoin does that.
Yep.
And commodities, they go up and they go down. And it shows you the folly of relying on a commodity for our energy. I mean, if you build a wind turbine, the price of energy for the next 35 years from that wind turbine. You know exactly what it is. It's not going to go up. It's not going to go down. It is. It's predictable. It's reliable. And a grid that runs on mainly wind and solar is going to have a predictable energy price. And, when I have an electric car and when I fill my tank, when I charge it, I know what I'm going to be paying now. I know what I'm going to be paying in a year. I know what I'm going to be paying in a few years. Whereas if I had a gas car, internal combustion engine, I would have no idea what the price of gas is going to be next year. And that is extremely economically painful. How do you plan if you don't know what the price of energy is going to be in a year, if you're a business? You basically have to say, well, it might be really high, so I'm going to underinvest. I'm not going to invest as much now, so I have this buffer in case the price of energy goes up. In a world of renewables where you have predictable prices, that's a significant savings and economic boost that renewables give you over fossil fuels. And let me just add one thing. There's this disease I call renewable derangement syndrome, which is that anything that goes wrong, people blame renewables. So, someone goes to, one of these RDS sufferers goes to the restaurant and their steak is undercooked. It's like, it's wind turbines' fault, or their girlfriend leaves them because all they do is complain about solar energy, or their dog pees on the rug in the bathroom. And so people actually look at this price run up right now and they say it's because of wind and renewable energy. And I mean, it's just anybody who makes that argument, I think, kind of disqualifies themselves if you don't mention the war in Ukraine, if you don't mention COVID, if you say it's just renewables, you're disqualified. Now, I'm not saying that when drillers make investments, they're not thinking in the long term, but it's a free market of energy, and they've made a decision that they don't want to drill. That's just, they're not going to get a good return on their investment if they drill at will. If they thought they would get a good return, they would do it. And so, it's the free market working, and it's possible that people think climate change is going to have some impact on the market at some point in the future. But, these shale wells don't last very long. So it's really, they just don't want to lose money because if everyone over drills, the price is going to crash, and people are just not investing in drilling in the U.S. for that reason.
I've got a few questions on that, actually. So firstly, with the renewable derangement syndrome, there is a lot of evidence that's presented by various people against wind and solar, which we will get into that. But it always feels like the criticism of renewables seems to come from like a political bent. seems to be politically motivated.
Yeah.
And so that's one of the things I've been aware
And
of.
I would just say, I don't think there's a lot of evidence that's presented. I mean, you hear people say stuff, but then if you actually say what's the basis for that, they just repeat you're a terrible person. And, I mean, it's hard to get into a debate about data. And so, I'm happy to talk about that, hopefully.
Well, we were. I mean, I remember during was it the big freeze in Texas when
Yeah.
ERCOT failed? Wasn't that initially blamed on wind turbines?
Actually, very interesting. So initially, they told the truth. So Greg Abbott, like the night of, goes, we've had major failures in natural gas. And then you could tell they kind of got together and they said, well, this is an opportunity to blame renewables, even though it's clearly a problem with the natural gas system. That was the prime cause. They said, let's blame renewables. Let's blame the Green New Deal, which doesn't even really exist. There is no Green New Deal. I mean, it was a document that was written by some people. There's no bill, there's no law, there's no policy. And it's just done for political gain to try to take the heat off their favored energy source, which is fossil fuels, and put it on an energy source they don't like, which is...
And is it a favored energy source because of the history of Texas being oil and gas?
Yeah, certainly that's a big part of it. But I mean, ultimately, it all comes down to dollars. And if you look at who gives money to politicians for their reelection campaign, it's the oil and gas and fossil fuel hydrocarbon economy gives enormous sums of money to politicians. And so a lot of politicians are essentially wholly owned subsidiaries of Exxon and so they do their bidding. And when they say, we don't like this bill imposes costs on us, the politicians carry their water.
Right. Okay. Just back to your car. Interesting. Just a question. I've never owned an electric car.
They're great.
Yeah. I mean, there's been a flood of great models coming onto the market. I've been in a Tesla now, and I think it's pretty cool. But the question I really had is, are you able to calculate the cost of what it costs to charge each time? Does it give you a cost? And how does it compare? So I know in the UK it's very expensive. It's about £100 to fill up my car with diesel.
Right.
And then from that, I'll probably get, let's just say 500 miles, just as like.
I've done exactly that calculation. Actually, I tweeted it out. So I drove 12,000. Actually, I don't drive it. My wife won't let me drive it. She drives it. She drove 12,500 miles last year at 30 miles per gallon, which is about what we have a Mustang Mach-E, a comparable sort of crossover SUV would get about 30 mpg. You can calculate that would be, and I'm using like $3.25 per gallon, which is pretty cheap. I'm doing that to be very conservative.
It's not that right now.
It's absolutely not that. But I'm just saying, let's average that over the last year. And so I'm being super conservative. It would have cost about $1,300 in gas. Now, I get about 3 miles per kilowatt hour, and a kilowatt hour costs about 13 cents where I live. And that works out to about $500 in electricity. So just there, I'm saving $850 on charge. Not to mention the fact that I don't ever have to go to she doesn't ever have to go to a gas station, which she really likes. You don't have to spend 5 minutes filling your car. And electric cars are more reliable. They have few moving parts. So you don't have to take it. You don't have to take it for oil changes. You don't have, fewer things break down on it. It's had no mechanical issues at all. It hasn't been in the shop, even for like a 7,500 mile, tune-up service like that. And so, if you figure that costs, a few $100s, we're saving probably $1,000 a year with the electric car. And so if you own the car for 7 or 8 years, that's more than the price difference between this and kind of a comparable car, even though because I acknowledge the initial purchase price is higher, but then you save the money over time.
But when the price of gas doubles, which essentially it could, or if even it goes up 50%, is there an increase in the cost for charging your car because it's part of the network, part of the energy grid comes from fossil fuels. So have you seen an increase in the cost of charging?
So the way our provider works, so in Texas, they have a deregulated energy market. So we get our energy from College Station Utility. They have a fixed price. So as the price of fossil fuels goes up and down, we don't see a price. Every year they adjust the price. So we get a lot of power in Texas from natural gas. Natural gas is incredibly expensive right now. And so our price of electricity is going to go up. And that will increase the price of power at some point. Now, ultimately, though, so I will say I'm getting solar panels in my house. Haven't been installed yet. I will be getting those. So that will drive down the price of that. But ultimately, until the grid is cleaned up, then the charging price is slaved to the price of the fossil fuels in some sort of long-term sense.
Yeah.
But as you clean up the grid, you decouple that.
Yeah.
And again, all of this discussion, just to remind you, all of this discussion is because fossil fuels are a commodity. If you get away from that, you go to renewables, you'd never have to worry about what is the price of energy going to double? It's never going to double. I mean, imagine a world where you know what the price is going to be in 10 years. And right now, no one has any idea what the price of energy is going to be in 10 years. And so, this is a significant benefit to renewable energy, this sort of predictability of the cost.
And as you clean up the grid, as more is invested in wind and solar, my assumption is the cost of production will come down due to the economies of scale.
Yeah, that's right. So wind and solar are the cheapest energy sources. A grid that's primarily wind and solar will be cheaper than a grid that's running on fossil fuels. So the price will come down. And again, it will be, it'll also be predictable. And you'll know exactly, it'll be at a low price, and it'll be at that low price, in the long term for decades.
I think it would be good just to run through kind of, in terms of research from the likes of yourself and climate scientists, where are we currently? Because if you follow the news, you follow the news reports, we keep hearing we're closer and closer to the doomsday moment. Now is the final moment, and then the final moment keeps getting put back.
Right.
And COPA has their big meeting, and nothing is really agreed. So it feels like the needle keeps getting pushed back.
Right.
And that creates a problem of trust, because if we keep having these doomsday moments and then 5 years later we have another doomsday moment, I think some people start to think, well, is this really that big an issue? Yeah.
So if we go to slide 1, that's probably, we can start with number 1. This shows what our, so this is a plot. The horizontal axis, the x-axis is year, goes from 1900 to 2100, and the y-axis is temperature. And the purple line is the historical temperature. Now, just to let everyone know, these are actually all coming from a model. So the purple line is actually, they're computer simulations of the climate. The purple line is the historical simulation of the last 150, 120 years from computer models. And it agrees quite well with observations. I can show you observations in a second if you're interested.
And so the people are listening from 1900 to around 1950. It was growing. It dropped back down around maybe about 1960. Then started to grow again. And from
about 1975, the temperature started going up.
From about 1975 up to around, about 2010, we've seen a rise of what seems about 0.25% to about 1% rise.
Oh, that's degrees Celsius.
Yeah.
So from the mid 70s to today, it's about a degree Celsius, about 2 degrees Fahrenheit of warming. And again, remember, I'll show you another plot in a second.
But what stands out for me on this chart for the people who are listening is that from the mid 70s to now, there seems to be a breakout in the temperature.
Yeah, that's right. So the temperature is going up. And what you see is, so then we also have the future projection. So there are 4 different scenarios, because we don't know we don't know what kind of world we're going to live in. Are we going to live in a Dessler world, or are we going to live in an Alex Epstein world? So he's the red line and I'm the blue line, I guess. And if you say, where are we? And so the blue line has about 2 degrees Celsius of warming in 2100. And the red line has 5.5 degrees of Celsius, 5.5 degrees of warming. And just, I put it in there in words. The last time the global surface temperature, this is from the IPCC, by the way, quote from there. Last time the global surface temperature was sustained at or above 2.5 degrees Celsius higher than the 1850 to 1900 average was 3 million years ago. So within a few decades, we could be out of the temperature range of the last few million years. And the other thing to realize, I think this is really important for people to understand, is there's a big spread. If you look at the lines, the difference in 2100 between the different policies, the different ways the world could evolve, is enormous. Okay, so now I don't plan on living to 2100, but as I said, my kids do. And as I tell my undergrads, you have skin in the game. The world you live in will be decided by the decisions we make in the next decade or two. And do you want to live in the blue line world, which has 2 degrees of warming in 2100? Do you want to live in the red world, which has 5 degrees of warming? And the red world, I have to say, this because I know I'll get criticized for this, it would be hard to be in the red world. I mean, you really have to burn every hydrocarbon. We are on track. If you say, where are we on track for? We're on track for probably the orange line. So that's about 3 degrees of warming in 2100. But if you listen to people who say we should be burning more fossil fuels, that will push us up, because that orange line assumes that we sort of go to net zero later in this century.
Okay, so just so people who are listening can understand, in every model, there's kind of an acceptance that there will be a continual growth up until around 2025, whereas Andrew's model starts to tail off, assumption because of mitigation.
Exactly.
The orange line may be the accepted line. It does seem to slow down, and is that because of the logarithmic effect?
No, that's because of policy.
Right
now, sort of under the Paris Agreement, the U.S. is going to go net zero in 2050. China is going to go net zero in 2060. If you kind of assume all of those things happen, you end up with the orange line.
Okay, and whereas the red line is the kind of high risk line, but
that's the world where we need more fossil fuels.
Well, that is what Alex says we should do. Like one of his pitches is that we need to, like humans flourish with because of the burning of fossil fuels. Lots of people live in poverty.
Let me just interrupt real quick.
Yeah.
That's a very clever trick. Humans don't flourish because of fossil fuels. Humans flourish because of energy.
Okay,
and he makes that point in a way that I think is confusing and not completely accurate. That what we need is energy. We don't need fossil fuels. And I don't disagree with the idea that humans flourish with energy.
Well, I think what he is saying is, yes, I think he's saying that, but with that, he's saying one of the easiest access for people who are living around the world and maybe living in more challenging third world environments is access to fossil fuels. And with those fossil fuels, they can industrialize. I think that's what he's saying.
That is what he's saying. I don't think that's right. I mean, how's that going? We've had fossil fuels for 100 years. Why are countries poor? Why have they not built fossil fuels and industrialized? And well,
Alex pointed to policy. Could you remember that article we found? He pointed to policy with regards to places like Africa, where actually they're being incentivized not to use fossil fuels, and they're being incentivized to avoid that. And so it'd be worth trying to dig that up, because I did challenge him on that, and he did come with receipts for that. But yeah, I mean, look, Alex, in context of what you're saying here, Alex believes we should burn more fossil fuels, right. And if we do, the impact is that we could by 2100. But I have kids too. I think they would hope to be around in 2100, and they would be living in a world up to 5.5%. 5.5 degrees warmer.
Yeah, and let me just emphasize, that's an absolute upper limit. I think you'd really have to make an effort to warm the climate to get that. But certainly you could do a lot higher than 3 degrees. If you go to the next slide, this I think is the same slide, but I've plotted it in ice age units, where again, so this is exactly the same data, everything's the same, except the y-axis tells you what fraction of an ice age it is. And so, and irritatingly, I just realized the line colors are different now. My apologies.
Yeah, that's fine.
Apologies for that.
I still recognize.
And so you see is that, if the best case is we get about 35% of an ice age, of a warming equal to the warming since the last ice age, and that is even the best case is an enormous amount of warming. That's going to radically change the face of the Earth. And the worst case is we get about an ice age of warming. And again, that's going to be hard to do. But I think that if we make an effort to burn all the fossil fuels, we could do it.
Is there any other slides that go with this that you want to show?
I go to slide 4. Because people always come up with how accurate are climate models. And so yes. I just want to show you 2 plots. The plot on the left shows the same. This actually shows the observation. So the x-axis is the same. It's still the year. And the y-axis is temperature change. So it's a very similar plot, but it only goes up to 2020. Okay. So we don't have any future. And the gray line, we're looking at the one on the left, is the observations. And in 1975, this extremely famous climate scientist, Wally Broker, wrote a paper where he made a prediction of what the future climate would be. And those are the red dots.
Okay.
And he nailed it. And I think it was not an obvious prediction. You would not have predicted that based on if you just had the historical part before 1975, you would not have predicted that would have happened. But it's a prediction he made because he understood the physics of the system.
This was the Exxon scientist.
So that's the one on the right. The one on the right are Exxon's predictions from the early 80s, and they also nailed it.
Yeah. So I once interviewed who was the guy who wrote the book, The Decade We Had to Change the Climate?
Nathaniel Rich.
Yeah, Nathaniel Richmore, and he wrote about that back in the 70s, climate scientists were all in general consensus with this, even those who work for Exxon, that the burning of fossil fuels would lead to a rise in climate change, and we had an opportunity at that point to deal with this, and then it became politicized, and then the oil and gas industry adopted the tactics of the tobacco industry in terms of PR to effectively create arguments regarding this and debates regarding this, which kind of pushed it to the side. Is Nathaniel accurate with that?
It's always hard to argue about sort of these counterfactual worlds. I'm deeply skeptical of that. If you look at the work of like Naomi Oreskes and Eric Conway, Merchants of Doubt, I don't know if you've seen that book.
Yes, yeah.
The Merchants of Doubt were operating in the 80s on acid rain, on ozone depletion, things like that. I'm quite skeptical that there was any way we could have gotten policy through at the time, but I suppose it's possible.
Okay. I mean, look, we'll share this in the show notes. In the video, we'll put this up. People can see this model is accurate. There have been models that have also been inaccurate.
Not really.
No?
There's
where does that argument come from then?
I think it's climate derangement syndrome. If you look at, there was a paper that came out a few years ago that looked at all of these old IPCC projections. And they're all incredibly accurate. For global average surface temperature, we've nailed it. And there's just no there's no evidence. Maybe if you go back to the 70s and the 60s, there were people who were not predicting it correctly. But by the time we got to the 70s and the 80s, their predictions were spot on.
Right. Okay. So we're pretty accurate now.
And I think let me just add one thing. I think that means that you can take the predictions of the future very seriously. You should take them seriously. Those predictions, I would bet my mortgage, are going to be right. If you give me the emissions scenarios, I can tell you what the temperature is probably going to be.
Okay, so those who are in the camp of in denial or, sometimes people hate being called climate change deniers. They say this is an attack on us. We're practical, we're rational. But when people come out and say the models have been wrong, that's generally
wrong.
False.
That's false.
Okay,
yes.
And a similar point that some people raise is that, well, climate's always been changing.
Yeah, that's right.
Yeah.
And so that's not a very good argument either. We understand the climate has been changing. You can look back at the paleoclimate record and you can see how, there were times the Earth was completely covered with ice, a period we call snowball Earth 700 million years ago. There were periods when there was essentially no ice on the planet, like when the dinosaurs were alive 70 million years ago. There was very little permanent ice on the planet. And so we understand that. But we also understand the mechanisms that drive that. And in fact, I have a slide. If you want to go to slide 8, I have my, I don't know if this has any cultural relevance anymore. I think when I originally made a version, go to the next one, 8. Yeah, that's one. This is from The Usual Suspects. I find that as time goes on, my cultural references get more and more out of date. So this is a fantastic movie if you haven't seen The Usual Suspects.
This came up in conversation last night because we're not sure if Danny's seen it.
I don't think I have.
Yeah, so we're probably going to watch it today.
It's really a great movie.
Yeah.
I mean, I can't emphasize too much. Anyway, we know what's caused the climate to change in the past.
Okay.
And so we can go through them and we can look at them one by one. And we can say, okay, well, can this one have done it? Can this one have done it? This one done it? Think about like a detective. If a house gets burglarized, somebody had to do it. So there has to be a physical mechanism. There's no natural climate change. There's non-human climate change, but it all has to be traceable back to physics. And so, for example, we know that the movement of the continents, continental drift, plate tectonics, we know that can change the climate, but that's too slow.
Okay.
Over the last 100 years, the continents haven't moved very much.
Okay.
We know that if the sun gets brighter, that's going to drive warming. But we've been measuring the brightness of the sun since the late 70s, during that period where the temperatures went up, and the sun is not getting brighter. The Earth's orbit can change, and that's actually what drives ice ages. If you ask why do we have ice ages, it's orbital variations. But again, ice ages are 100,000-year phenomenon. They're not centennial scale, so they're too slow also. The Earth's orbit just hasn't changed since the 1970s. It's about the same. And then there's ocean cycles, or what in the climate biz we would call unforced variability. And that's changes that are not forced. Like when the sun gets brighter, we call that a forced climate change because it's being forced by this increase in energy falling on the earth from the sun. So that's a forcing. Unforced variability are things like El Niños. It's just the Earth's system is complicated enough. You have these nonlinear interactions between the atmosphere and the ocean. And so El Niño, La Niña cycles are, we call the El Niño Southern Oscillation, ENSO. It's referred to as ENSO. So that would be like ENSO variations are these unforced variations. And there's no theory. No one has come up with a hypothesis of how that could be driving it. Because there's no hypothesis, you can't test it. I can't exclude someone as a suspect until you bring me the suspect. Because once there's a hypothesis, then I can develop a test and we can test it. So it's really hard to exclude unforced variability because no one's come up with a theory. So when someone does come up with a theory, we'll test it. But that seems very unlikely because people have been thinking about that and working on that. Models don't generate it. Models generate other modes of internal variabilities, these climate simulations that we know about. They generate El Niños, for example. They generate other variations. They don't generate anything that looks like it could cause the warming we've been seeing over the last century. And so that leaves greenhouse gases, which I like to call the world's dumbest criminal. The criminal who drops his wallet at the crime scene, who leaves fingerprints. There's actually a security video of him carrying the stolen material out of the house. When he was arrested, all the stolen stuff was in his trunk. He was bragging to his friends that he did it. That's greenhouse gases. The amount of evidence that it's greenhouse gases is overwhelming. It's just, the physics tells us that if you add a gas, and by greenhouse gases, let me just say, I'm talking about things like carbon dioxide, methane. These are gases that absorb infrared radiation. If you add an infrared absorbing gas to the atmosphere, just based on physics from the 19th century, they predicted, well, that's going to warm the climate. We know we're doing that, and we're seeing the climate warming. In addition, we look back in the paleo record, things like variations of the last billion years. We see that these variations are often tightly associated with carbon dioxide. If carbon dioxide wasn't doing it, we wouldn't understand any of those variations. And so, I could go on about this. I teach a whole class. I go over this for a whole semester in my climate classes, so I could talk at great depth about it. But I'll just sort of say there's no question that humans are now the dominant driver of the climate system. So we've got our foot on the gas, and unfortunately, we don't have our hands on the wheel.
So you said you and Alex agree on things, and one of the things you agree on is that the global temperatures are changing and that humans are responsible. But Alex also argues that there is no direct link between temperatures and CO2, stating that historical records show that CO2 level rises are after temperature increases. We've only had as evidence, we've only had a 1% temperature change while CO2 levels have doubled. Changes to the climate are not necessarily due to man-made CO2. Further, the greenhouse effect has a diminishing logarithmic effect. Okay, so we've agreed on that last point.
Right.
But he's saying there is no direct link.
Yeah, that's all wrong. There's a bunch of misinformation kind of stuffed into a little package there. So talk about the CO2 lag. So he's talking about ice ages. And during the ice ages, the change in temperature does precede the change in carbon dioxide. And the reason you have to understand again, it all goes back to the physics. The reason is that during the ice ages are paced by orbital variations. As I said before, it's the changes in the orbit that cause the carbon dioxide, that cause the climate, cause ice ages. So what happens is the orbit changes, that causes a small change in the climate. Through ways that we're not 100% sure, that then drives changes in carbon dioxide. So it's the change in the climate that drives the change in carbon dioxide. Then that carbon dioxide acts as a feedback to amplify the warming. I had a slide which I took out. I thought, there's no way this is going to come up. But I actually had a slide on carbon cycle feedbacks, this idea that the warming climate can change carbon dioxide, and then that gives you more warming. And in fact, in the 90s, when they discovered that carbon dioxide was varying during the ice ages, before that, nobody could explain the ice ages. One of my colleagues at Texas A&M, Jerry North, spent like 10 years in the 80s trying to explain ice ages. And once we realized that carbon dioxide was a feedback, was being changed by the temperature, that then explained how you get these big ice ages. These ice ages are huge swings, 5-6 degrees Celsius, and you need carbon dioxide. But the change in temperature comes first from the orbital variation. Now, that's different from what's happening today. Today, humans are pushing carbon dioxide in the atmosphere. So that's what's driving the warming. So there's this idea that carbon dioxide changes happen after temperature. That's just a complete misunderstanding of the science. I mean, I'm surprised. I've never heard him say that. I'm not saying he didn't say that, but that's absolutely wrong, 100% wrong.
One of the other interesting things with regards to this is that I actually think the majority of the debate should be with regards to mitigation and impact.
I 100% agree with that.
And to get to that point, you have to have an agreement that the science is correct,
right?
That the predictions are pretty good and the models are pretty good.
And in fact, that's why people argue about the science, because they don't want to have that debate. Once everyone agrees on the science, then you move to policy debate. And I think the fossil fuel interests kind of know they're going to lose that debate. And so they want to keep the debate focused. This is a strategy to keep it focused on science.
Okay.
It's not, there's nothing legitimate in their science. There's no legitimate objections to climate science. Let me just be clear about that. There are things we don't know, but we acknowledge we don't know those. There are things that we know very carefully, with high degree of certainty. And there's really no question. We know the Earth's warming. We know humans are the dominant driver of climate. We know future warming will be a few degrees Celsius. Those are things that are not debatable at this point.
Okay, that's fair. So do you think the challenges to the science directly come from within the oil and gas industry?
Well, I don't know if it's just the oil and gas industry, but it's people opposed to policy. It could be people that are opposed to government action. There are people out there who say, government should do nothing in the world. I mean, I think Bitcoin has a lot of kind of people like that in that world. So I'm sure you've run into them. There's no role for the state to do anything with regard to, anything. And so
the libertarian free market.
Yeah, exactly. Yeah. So I think that those people also play a role in this, as in addition to the people who are politically who are financially motivated. And let me just say that probably the thing that worries me the most is that the energy debate is going to enter the broader culture war, like COVID vaccines, for example. And it won't.
I think it's already there.
Yeah, I mean, this is really what worries me. So it's not even going to be about people who are motivated by a particular financial incentive. It's going to be how you show your loyal to your tribe. If I'm going to talk about how terrible windmills are, that I'm going to do that, and that's going to show all my friends that I'm a loyal member of the tribe of people who despise. We despise intellectuals. We don't believe in climate change. It becomes this shorthand notation for it. And I think that's one of the ways that we could fail to solve climate change.
Yeah, so that's a really interesting point, because it's something we've covered on the show quite a bit. It's something I'm particularly interested in as somebody who travels between the US and the UK a lot. And I would say in the UK, I'm considered a conservative, and my conservative friends in the US think I'm a lefty. But I've had a good lens for seeing, not only in the media and on social media, but in my interactions. I spend a lot of time in different parts of the US. In our last few trips, we've been to New York and California, but we've also been to Austin and Dallas. We've been here in Nashville. We've been to Miami. Where else have we been? DC. And so I do travel to both Republican and Democrat areas. I do follow the news. I do follow the influence online. And there is, feels like to me, there is now this hard line. On one side of the line, to the left of it, is, I'm generalizing here, but more broader concerns about climate and wanting to move to renewables, pro-choice, anti-gun, higher concerns with regards to COVID and vaccines. I'm very careful on the COVID one. On the other side, it is pro-Second Amendment, pro-First Amendment, pro-life, anti-restrictions with regards to COVID and lockdowns, more skepticism with regards to vaccines. That's just kind of like a general picture. You might agree, disagree. When I'm in the UK, with regards to, say, COVID and vaccines, I don't find a real split between those who vote Conservative and Labour. It just doesn't really exist. We don't have a Second Amendment debate because we don't have guns. Even with regards to climate change, Danny, correct me if you think I'm wrong here, but I don't tend to find there's much of a split.
No.
You will get ultra conservative people
Right.
who maybe fit in that, from the UK, fit in that Republican lens, that the contrarian.
Like the UKIP.
Like, yeah, well, it's yeah, kind of those kind of people, but they're a very small, tiny group. They're not pretty much half of the voting population.
Right.
I think climate skepticism in general is much more in the UK.
Yeah, there's a much general acceptance that this is an issue and we need to deal with it. And I think that would be across Europe. The problem we have here is the US tends to lead the way on policy decision, and the world follows, or we look to the US on certain things. And putting this into the culture war is a huge problem. And I think the media and journalists and influencers have a responsibility of finding the actual truth. And I accept we all have a bias.
Except I would say some of the media, this is their goal, is to, you go to Fox News, their goal is not to find the truth. Their goal is to actually, whip up this resentment.
I think CNN and Fox are like, as a neutral person, I can see them both playing the same game. I can see it.
All right. As a climate guy, I'm more attuned to what Fox says than CNN, but I take that. I accept your point.
Yeah, and I think what that is because like on your particular issue of climate change, CNN probably agrees more with you, and whereas the Tucker Carlson side of the crowd tends to disagree a bit more.
Right.
And so, like, I can see why you see that in your particular issue. I'm talking generally.
Right.
It doesn't feel like the US has very good neutral sources of news, which is why I looked at someone like yourself as an expert. So my audience, I don't know the percent that people would be Republican, Democrat. The public conversations, or those who tend to comment on YouTube, tend to be more, I would say, towards the right. And therefore, when I was challenging Alex Epstein, I got some very negative comments.
Right. Yes.
I do get a lot of positive private comments as well.
Yeah, don't read the comments.
Don't read the comments.
That's my my rule number one.
That's Rogan's advice and Danny's advice to me. With regards to this, there will be, I think, a higher level of criticism from my audience towards you, but I will definitely get a bunch of emails appreciating the fact you have on. This is a long lead up to a point I wanted to make, or a question I wanted to ask. You had the debate with Alex, and it was fascinating. It was fascinating, but I don't think it was well structured. I think it needed to be 4 hours long, and you both needed more time. That aside, you were willing to do the debate. If I had have asked Catherine, she would have said, no, I'm not even talking to these people. They're a waste of time. We should not engage with them. So why is it you chose to engage and others didn't? And do you think people should, like climate scientists, should be engaged in debates with people like Alex?
Yeah, so I think it's important to understand that there are really two issues here. One is the science issue, is climate change actually happening? And then the other one is the policy issue of what you do about it. And I absolutely agree with all of my colleagues who won't debate the science. Like, if the Steamboat Institute had approached me and said, climate change, is it real? Is it caused by man-made? I would not have done that.
Okay.
I mean, that's not something I want to do. But questions about should we do this? Those are questions that aren't decided by science. So science obviously is an input to them. You look at the science, but you also look at your values, and you look at your policy options. You look at how risk averse you are. You look at, all these things that are not science. And the only way to resolve policy debates is with public debate. And so, I'm happy to go out and debate policy, because I'm in addition to being a scientist, I'm also a citizen. Mm-hmm. And as a citizen, I have the right to go out and advocate for policies that I like. And so this is, and I get a much bigger platform. Most people can't do that. Most people have all of these ideas, and no one will invite them to debate someone on a stage in front of, 150 people, but they will invite me. And so I'm going to do that. I'm going to go out and say, these are the policies I think we should do. And so I don't want to criticize my colleagues at all. I think every scientist has to make a decision about how they want to spend their time. And I think that people like Michael Mann and Catherine Hayhoe, what they do is so valuable and so fantastically good that they should keep doing what they're doing. I don't mind going to very hostile audiences. And it's like, if you saw the Steamboat, after Alex would talk, people would cheer him. And then after I talk, it'd be like you couldn't hear a pin drop. And, I kind of get a charge out of that in some respects of telling stuff that people, I can just tell they don't want to hear. And my goal is not to convince them. My goal is just to plant a seed, give them the information so they can convince themselves. That the seed of information, then maybe next week they see a story in Forbes, and a week later they hear something from, on the news. And then after a while, it kind of grows into this different worldview. Because ultimately, on sort of, I do feel that we are going to switch to renewable energy reasonably quickly. I do think that ultimately everyone will understand that what the scientists are saying about climate is right. I'm just trying to get people there as quickly as possible.
And so this has to be solved, in your eyes, through policy. Again, you won't be fully aware of this, but a lot of people in the Bitcoin space lean towards libertarian or anarchist. They're very anti-government intervention, government regulation. As a British person, I'm very openly honest that I am a pro-democracy person. I'm reluctant. I say a reluctant statist because I don't think we have particularly great government at the moment. I think the impact of inflation comes from the government's mismanagement of monetary policy. But at the same time, I am not somebody who wants to see a complete collapse of the state. That's not the world I live in. A lot of listeners do. If your belief, therefore, is if this was left to the free market, nothing would be done.
Yeah, I have a couple of responses to that. So the first one is, let's talk about electricity. A truly libertarian electricity policy is everyone has solar panels in their house and a battery, and they just generate their own power. I mean, that's the libertarian electrical system. Once you have a grid...
I disagree with that.
No, once you have a grid, you have to have the government. Okay. I mean, you have to have rules. I mean, you have to have a manager of the grid, make sure there's enough power available. That's what ERCOT does.
Why can't you have a private grid?
Well, I mean, who's going to set the rules? You're going to let a company set the rules?
I mean, that's what they would say. Yes. Yeah.
But I mean, then the company's going to set the price of electricity just the way the drug companies in the U.S. set the price of drugs. 25% of people won't be able to afford it. 75% of the people will be paying 3 times what we're paying now. It's going to hurt the economy. I mean, sure.
I think I know where you're going, because
you could do that. Just like you could require everyone to generate their own electricity.
Is it because a grid by virtue of being a grid has to be a monopoly?
Yeah, I mean,
so there's no competition.
A grid is this unified structure. It's like a giant plant. And grid operators need to make sure there's enough power at every moment of the day. They have to balance the power supply and the power demand. And that's essentially the job of the grid operator. And that's what ERCOT does in Texas.
Okay.
They make sure there's enough generators producing power every day. So they're looking at the weather of the day ahead. They say, we need this many gigawatts at 4 p.m., and then they make sure there are enough generators. They do that through this auction system. I won't go into that. But you need to have a centralized organization. And once it becomes for profit, I think the system is going to fall apart. I mean, it will be a different world than the one we have now. A world where not everyone can afford power. And then you get to this idea of human flourishing. I mean,
So I'm just going to go back on that step. It's like if I go down to the shops there and there's 2 coffee shops, in a free market, they get to compete for my business based on the price they charge for the coffee and the quality and the service. And I make a rational choice based on those. So one might be better quality, but more expensive, and I'd rather go for the cheaper. And I get those choices.
Right.
But with a grid, I can't. Whilst you can have different providers operating on the grid, which we have in the UK, the grid itself, I can't switch grids. I can't this grid compete with that grid.
That's exactly right. You can't build a second grid and then have them compete. Yeah,
that's a really good point.
I suppose that's a different way to imagine. So instead of doing that, we'll build multiple grids, but that would be a big waste.
Yeah, okay, but that makes sense. That's the argument for that there has to be a centralizing force. And when there's a monopoly, you can end up pricing people out.
That's exactly right. Yeah. And that would inevitably happen. Exactly the same way it happens with drugs in the U.S. They set the price of drugs to maximize their revenue, not to make it affordable to everybody.
Yeah.
And so, to be honest, I had all these ideas I was going to respond. I can't remember. I do remember your last question, though, is do we need the government? And the answer is we absolutely need the government. And the reason you need the government to solve climate change is because the costs of fossil fuels go beyond the costs of digging up, refining, transporting energy. If those were the only costs, you wouldn't need the government, because then renewables could just compete with fossil fuels on price, and whichever one wins. But fossil fuels have these external costs. So economists would call them externalities. Climate change is a classic one. So the price of climate change is not priced into the price of gasoline. So if you go buy a gallon of diesel, or a liter of diesel, I guess, and you drive to the store to get some apples, the carbon dioxide you emit when you do that, that's going to stay in the atmosphere essentially forever on timescales that we care about, not literally forever, but on sort of the timescale of you and your kids. That's going to stay, and it's going to be changing the climate that whole time. And you don't pay for any of those damages. So right now, the climate damages we're experiencing were actually carbon that was emitted, 30 years ago, 40 years ago. We're subsidizing those people. And those people didn't pay for the damages that we're now experiencing. And so you have to internalize, if you want to have a market that works correctly, things have to be priced correctly. That's Econ 101. If things are not priced correctly, the free market doesn't generate the socially optimal result. And so things have to be priced correctly. That means you have to include the price of climate change. You have to include the price of air pollution deaths. Millions of people every year are killed or die. And then there's all these other health impacts of air pollution. It's very well documented. And then you also have to incorporate the issues with national security, the fact that it's a commodity that goes up and down. National security, let me just talk about this. So right now, or very soon, Joe Biden is going to go to Saudi Arabia, hat in hand, begging them to increase their production. I mean, this is not in the United States' best interest. This is terrible. Why should we have to go and beg a really terrible country? I guess I should now have to never go to Saudi Arabia.
Well, I'm with you on that. I mean, recently there's been a lot of global focus on the war in Ukraine and Russia, and a lot of sympathy towards Ukrainians. I don't think I'll ever go to Saudi Arabia because I've been very critical of the war in Yemen, which has largely been ignored because the UK likes to sell arms to Saudi Arabia, and also they murdered a journalist.
Yeah, no, it's terrible. I mean, the fact that we are forced to deal with regimes like that is there's a cost to that, and there's also national defense costs. We spend a lot of money making sure we can protect the oil supply lines. That goes to the defense budget, so that's an enormous cost. And then there's the commodity price swings. So all of these costs are not included in the cost of a gallon of diesel or a liter of diesel that you buy. And so, in a world where you're not paying the full price, which is the world we live in now, the free market's not going to work. And I understand people don't like to hear that, but that's just Econ 101. If you reject that idea, then you sort of say, we're going to stick with fossil fuels for a while. Now, I think at some point, renewables will be so cheap that even without, in fact, they're almost there now, even without incorporating these external costs, we will switch, but we're probably not going to switch as fast as we should. I mean, that's really kind of the challenge. If we want to switch in the economically optimal way, then we need to price these externalities into the cost of fossil fuels.
How connected are you to the work on policy, and is it lobbying efforts between scientific communities and people like yourself and Catherine? Are you guys working directly with lobbying for policy? How does it actually work?
Yeah, I don't really do that.
Okay.
So I communicate, I talk to people, I tell them what I know, but I don't work with advocacy organizations to push stuff. Occasionally they'll ask me to sign letters, like climate change is something, and I'll sign a letter for support of a carbon tax, for example. Carbon tax is one way to incorporate the externalities into the cost. That's why a carbon tax works. It makes people pay the full cost. And so I do that, but I'm not really a policy person. I kind of study policy, but I'm not really involved in the nitty gritty. It's just it's not what I like to do. I'm a data guy.
Okay. Talk to me about the Green New Deal. I listened to Tom Woods being very critical of it. Is it something you support or is it something you're against?
Well, so it's very important. The Green New Deal is kind of like Voldemort and Harry Potter in the sense that you're not really sure it exists. I guess Voldemort did exist, but maybe that's not a great analogy. But the Green New Deal doesn't exist. There is no Green New Deal policy. There was a paper that was written by some Congress people, AOC and I think Ed Markey and a few others. They wrote, I don't know how it was, a dozen pages saying these are some principles that we think we should be pursuing. Social justice, just some things, and it never went anywhere. So there was never legislation written. There was never a vote on the legislation. It was never signed into law. So you can be critical of the principles of it, But this idea that it's something which is having an impact on the world now is not correct. I mean, it didn't go anywhere.
Well, is ESG then the kind of follow-on from the Green New Deal?
Well, ESG, as I sort of understand, is more of a finance thing that, companies should be pursuing these environmental and social governance issues. I think it's completely different. They're apples and oranges.
Do you agree with ESG as a way to try and influence companies to be more environmentally friendly, or do you think it's something that's being butchered and manipulated? We recently had Elon Musk tweeting out that ExxonMobil had gone above them in some index.
Yeah,
and they dropped off.
Yeah, can I answer yes to both of those questions?
Yeah.
I do think, maybe this way, I'm a free market believer. And I think that when people divest when people use the power of the market to influence other people, that's the way the market's supposed to work. I mean, the market works when people influence other people. So if I'm a bank and I say I'm not going to fund any oil and gas deals, that's the way the market works. There's nothing wrong with that. And so sort of the overarching ESG effort to identify good actors and bad actors, I think is a good one. People that finance, if I were investing, I would not invest in a company that supported building coal-fired power plants somewhere. I mean, I just wouldn't do it. As an individual, it's my right to put my money where I want to put it. And so I think it's very useful to keep score. It's, people talk about these sunshine laws and sunshine regulations where people have to disclose what they're doing. And a lot of people don't want to do that because they're doing some terrible things.
Yeah.
But people, so I'm in favor of sort of, as a general principle, having scores and having more information available for these people are doing. I do think it's kind of ridiculous that I think Tesla has done a lot for the climate system. Without them, I don't know where electric cars would be. I know people don't like Elon Musk for a number of reasons. I think going to Mars is a dumb idea, but nonetheless, I think Tesla's great. I think SpaceX is great. I respect, I think you can think multiple things about somebody at the same time. And I have a tremendous amount of respect for a lot of the technical stuff he's done. I think it is ridiculous. I mean, Exxon, there are a few companies that have done more to destroy the planet than Exxon, it seems to me.
Yeah, and it's a really great point you make that Tesla has essentially accelerated the expansion by other automobile manufacturers to push towards electric. I think that's probably driven by the fact we reached that point where I think the market cap for Tesla was all the other companies or something put together. Yeah. Some ridiculous stat like that, but they could see the growth that Tesla was having and they realized this is something they needed to do. So I think a lot of the companies were essentially reacting to that. I just want to pick you up on something you just said though, because you said you're a free market advocate, but at the same time, you think policy is important here. And part of the policy would be to perhaps subsidize the build out of green energy and perhaps remove certain subsidies that might exist or benefits. Right. So I think for context, I think personally, correct me if I'm wrong, you like information to help people make ideas, but a pure free market is in contradiction to policy.
I don't know that a pure free market, markets have to have rules.
Okay.
And who establishes the rules? It's like, can you think of a market that doesn't have rules in it?
Well, I just think in a pure free market doesn't have rules. I think that's the kind of idea that a pure free market. For example,
so maybe it's a definitional issue. I don't. I think that most markets, especially for important things, have to have rules on them, okay. And because otherwise, and it's mainly because of externalities. If companies are just trying to maximize their profit, they are going to try to push as many costs as possible onto society and not pay those themselves. And you really can't let them get away with that.
Yeah, no, I agree with you. I again, going back to Nathaniel Rich and his study into DuPont was particularly interesting for me in understanding that I think some companies just don't give a shit. Yeah. And they will pollute waters, they will pollute land. I think
it's actually worse than that. What they do is they lobby really hard to get the regulations on some terrible activity removed. And then when they get caught doing it, they say, we're following all the government guidelines.
Yeah.
And so, but they fought to set these guidelines at levels that allow them to do terrible things. And I have to say, I have sympathy for the people that run these corporations. They're being judged on their quarterly profits, not on the long term. I don't know if you saw the guy as HBSK. I think he was like there was a YouTube video of a guy from a bank. It's like I can't remember the initials. I think some Hong Kong bank. And he gets up there and says, the market doesn't care about climate change. And he got just torched online. And the thing about it is, he was telling the truth. The market, who only cares about the next 10 years, doesn't really care about climate change. If some action they were going to do was going to give them a big return in the next 5 years and might end the planet in 150 years, they would do it.
Well, I think you can make a very similar argument for the government. I don't think the government gives a shit about climate change. I think they give a shit about the next 4 years.
Yeah, that's right. I agree. Especially, they care about the election cycles.
Yeah,
that's
election
absolutely
cycles.
right.
And I think the election cycle causes massive problems both within we talk about it within Bitcoin. The reason we care about Bitcoin, just a very quick version, is that we don't like the expansion of the money supply because it pushes the cost of government mistakes onto the individual through inflation. And in the short term, the government will print as much money as they want because they have things to pay for, kicking the can down the road for the next election cycle. So you get this build-up of issues within the system, which is why we're seeing massive inflation now. I think it's a very similar thing. The point back to the ESG is how free market are the ESG indexes, who creates the index, what is the measure? That is the thing that I think is most concerning about ESG. I, as an individual, would love to know. I'll get hammered for this by some of the listeners, but I would love to know the footprint of some of the companies that I would choose to work with. But it's like the fact checkers. Who facts to fact checkers?
No, I like I said, the idea that Exxon was above Tesla just seems, absolutely ridiculous. There's no doubt. And I would just add that most politicians don't care about climate change. There actually are some really good ones.
Of course. And, I'm being general. Yeah,
I can name 5 or 10 that I think really do care about the long term and are willing to, put some political capital on the line to try to save people in 100 years.
All on the Democratic side or anyone on the Republican side?
Are there any on the Republican side? None that are in office. There are lots of Republicans who, once they get out of office, say, this is something we need to deal with. But when they're in office, they can't get reelected. They'll get primaried. And a lot of this goes back to, how the U.S. political system works, how we have primaries, how they've gerrymandered districts. It's really hard for you to buck the whatever the party line is. And in fact, just a few days ago, there was a Republican who said, we should ban assault rifles. And he immediately announced he wasn't running for reelection because he got so much pushback. It was clear he was going to lose his primary. And that's kind of the level of message discipline they have. So,
that was what Steve Kerr said when he with regards to after the shooting here in Texas. He said, with regards to politicians, they have their main issue is they want to retain power.
Right.
And if they want to retain power, they can't make certain decisions because they can't go against party line. So this isn't an argument about the gun debate, but this is the issue that people who are trying to work towards policy change to protect the environment are running up against many other issues. And the reason I bring it up is, 2 years' time, there's going to be another election. Yeah. And I don't think the Biden administration has had a great time.
I think I agree with that. We're going to have an election this November for the House and a third of the senators. So, things could look very different in a year.
Which would affect the work that the likes of yourself and Catherine and anyone who's actually, on the policy side is working towards. Anyway, we've gone down a bit of a rabbit hole here. Let me bring it back to impact and mitigation. For you say the science is absolutely clear. I agree with you. I'm not somebody who challenges the science. I hear the challenges. I will get yelled at once this comes out, but I agree that the science has been settled.
I'll get yelled at too.
Yeah, I've done my research. Within those who are doing the work on understanding the science of potential warming, what is the level of quality of work you believe that's done on understanding the impact? Because that's a different point.
Yeah, that's a lot harder because the impacts depend on what humans do.
Yeah.
Just to give you one example. So after Hurricane Ike almost wiped out Houston in 2008, I think it was 2007, one of those 2 years, we started talking about building a coastal protection for Houston to keep a big storm.
27 billion or something?
Yeah, it's like 30 billion. Yeah, so very close. And, we haven't done anything on it. And, Houston's a sitting duck for a big major hurricane driving 20 feet of storm surge up the ship channel. There's a giant petrochemical industry. If they did that, they would destroy all the tanks. It would release millions of gallons of chemicals. One person really memorably called it would be America's Chernobyl. I mean, it would be that big of an environmental catastrophe. And, we're not building it. I do think actually they might just be now getting money to start building it. But the point is that adaptation will be determined by what humans do. Now, a few important points. A lot of adaptation is extremely expensive.
Yeah.
So building seawalls is expensive. Relocating cities. You look out what's going out in the western half of the U.S., Lake Mead and Lake Powell are drying up. Water is very scarce. In Los Angeles, there are water restrictions. So, these things are you can adapt, but they're painful and they can be very expensive. And so, again, the real question is, what's kind of the cheapest route? Is it cheaper to pay for this adaptation, or is it cheaper to pay for renewable energy? And it's quite obvious to me that it's cheaper to change our energy system to avoid that climate change rather than experience it. Now, there's some climate change we cannot avoid, and that we have to adapt to. But we have, as you saw from that plot I showed you, there's a big range in 2100 between what the choice we make will determine how much adaptation we have. But nobody has any idea how much it's going to cost, and there's a million ways that it's going to affect us. I saw an article in I think it was the Washington Post just yesterday or the day before about how high temperatures is schools that aren't air conditioned in like Philadelphia and New York. They have to close them on days it's too hot. And so those school districts either have to install air conditioning or they just have to cancel school on those days. So, I mean, there's a million ways that we have built assumptions on what the climate is into our society. And every one of those is going to have to be adapted. In fact, I have a slide I can show you.
Let me ask you a question on that, because the rational side to me would say, if there's a general increase of 2 to 3 degrees, I mean, I know, in the UK, whether it's 20 or 23 or 23 and 26, that's not a big difference. But they're localized. That's like an average variation.
That's the global average.
Yeah, but do you actually get more volatile swings because of this? Is that what's happening?
Yeah, so I'm not sure so much variability is going to change, but the point is, okay, so let's sort of talk through the numbers. So 3 degrees Celsius of global warming, that's the global average. So the northern hemisphere is going to warm more than the southern hemisphere because the northern hemisphere has more land, and land warms more than the ocean because of heat capacity.
Yep.
So you could get twice as much warming as the global average. So 3 degrees Celsius would correspond to 6 degrees Celsius of sort of local warming. And so let me ask you a question. On the hottest day, would you want it to be 6 degrees Celsius hotter? I mean, pick a heat wave and now make that heat wave 6 degrees Celsius hotter.
Only in the UK, because the hottest it gets isn't that actually that bad.
All right, well,
so it'd be like being in Barbados for me. But I get what you're saying. If you're in India and you're used to 40 degrees, you go to 46, it's a massive jump.
That's right. That's right. And in fact, and it's not so much just the comfort level for humans, but as I said before, we have built in assumptions on the temperature range everywhere through our world. So just if you could go to slide 32. Just look at the one on the right. So these show train tracks, and you can see that there's this kink in the train tracks. So what causes that? Well, what happens is when you build train tracks, you ask because the train tracks expand and contract when the temperature changes, and so you have to ask what's the temperature range that these train tracks are going to experience. And so the people who build it say, okay, well, let's look at the last 30 years. Here's the temperature range. Let's add 2 degrees to that for a little bit of, the hottest temperature, add a few degrees just in case. And you end up with these gaps in the rails that are supposed to accept the expansion. And then what happens is as climate change comes, all of a sudden you're getting temperatures you never expected to get. And all of the engineering that went into the world no longer applies. So in this case, the tracks expand into each other. They don't have anywhere to go, and you get these kinks. In fact, there's a name for that called a sun kink. And these things are everywhere in the world. The one on the left shows a bridge that expanded so much they couldn't open it because it expanded and
is it one of the?
Yeah, it's it's a drawbridge. It expanded, and so I can point you to the schools in Philadelphia, not putting air conditioning is an adaptation because, okay, well, here's the temperature range. We don't need to air condition that building. Maybe there's one day every 5 years that's uncomfortable. And then with climate change, it's several days every year that become too hot to have students because they just can't concentrate and it's just too uncomfortable. And so this is going to be very expensive to essentially re-engineer our world for a world of warmer temperatures, because all this has to be rebuilt.
And some of this is going to happen anyway, because even in your model, you're accounting for a 2-degree rise, and these things are happening. So it's already happening.
Oh yeah, that's absolutely right. It's just a question of how much we rely on this.
Yeah.
And I think my personal opinion is it's a risk. We're rolling the dice if we want to say that we're going to rely entirely on this and we're not going to try to reduce the warming.
So is one of the best arguments for this is the economic cost of migrating to a more renewable grid is going to be lower than the mitigation required from, say, 2 to 5 degrees.
Yeah, I mean, look, the cost of migrating to a renewable energy grid is zero now, basically.
Well, we're going to have to dig into that.
We can dig into that, but it is basically zero now. And so it's absolutely going to be cheaper to do this and to build seawalls and to do everything else. I mean, we're at the point now where we can do it at very low cost.
Is there any work that's been done on the net impact of deaths caused by rising climate? So, for example, in certain areas when the world warms, in colder areas, you're going to have less cold deaths, but maybe you're going to have more heat deaths. Is there any kind of net impact study on that?
So if you look historically, if you look at the deaths over the last few decades, it is true that deaths in cold temperatures occur more frequently than deaths in warm temperatures. And I actually have a graduate student working on this, so I could speak in extremely high detail about it. That's a very misleading statistic, though, because what they consider to be a cold death is one that occurs below what they call the minimum mortality temperature, which is around 22 degrees Celsius. So if you look at the data, as the temperature drops below 22 degrees Celsius, deaths increase. I'm not sure why. So at 15 degrees Celsius, you wouldn't consider that to be cold. There are more deaths, and we can look at that statistically. We can see that. And so those are cold deaths, but they're really not like cold event deaths. There just happens to be the mortality increases. And as you go down to colder temperatures, it's a very gentle slope of deaths increasing with temperature. If you look at the hot temperatures, it's really steep. And so if you shift the temperature 1 degree, you will save a few lives on the cold side, but you will kill a lot more people. So it's very clear that as the climate warms, more people are going to die from heat-related events, even though it is true that more people die from cold now than die from heat. You're not going to save that many cold lives, but you are going to kill a lot more people.
And is that because we already see heat deaths, but that 4 or 5 degree potential increase in places that are already extremely hot? Even where you are in Australia, Danny, it's pretty hot, isn't it?
Yeah, I mean, it gets easy into the 40s.
Yeah, you're going to see that increase there. Okay.
Yeah, it's just that people are adapted to basically the temperature range they are living in. And if you think about it, if you're adapted to very cold temperatures and the temperature warms a little bit, that really doesn't help you that much. Whereas if you're adapted to a certain temperature, if the temperature goes to 45, that's going to be really bad. You're not going to be as adapted to that. And so I have research. I have a grad student working on that. We have a paper, should be out soon, and I'll be tweeting about that and really pushing that. So I think that's a real fundamental misunderstanding of the data when people say a warming climate is going to be good because it's going to save lives. That is absolutely not correct.
Okay. I mean, I go back to the point. Look, if the climate's, if the science is settled, which I agree with you, I think it is. I know people listening won't do, but I agree it is. I would love to see a lot more work done on impact, both on agriculture, migration of society, what happens on coastal regions, and then also the economics of mitigation. The economics of mitigation is going to be a very difficult model to produce, but to see that for the different temperature rises would be kind of interesting.
Well, mitigation is reducing your emissions. So that has nothing to do with the amount of temperature.
So I wonder about mitigating the effects of the actual climate change.
Okay.
Yeah, okay. So
how much it would cost? How much it would cost?
Adaptation.
Oh, okay.
So I should have said adaptation, not mitigation. Adaptation. Right. That I think the models on adaptation would be.
Well, as I said, it's really hard. Calculating the cost of adaptation is really hard because you really don't know how humans will respond.
Yeah.
And unlike an electron that does what you want it to do, or a CO2 molecule does the same thing every time, humans don't. And a lot of it will depend on whether humans are because here's what adaptation comes down to, and this is why I'm so troubled by it. So during the Texas blackout, that was terrible. You weren't there for that, but trust me, you do not want to go through several days at 5 degrees with no power. And so after that happened, you think, okay, how is Texas going to respond to this? So one way we could have responded is we could have hardened the grid. Like, let's because we know what happened. Natural gas production crashed because they weren't weatherized. And the government could require them to weatherize. In North Dakota, they produce natural gas at much colder temperatures. It's just a choice by the natural gas producers to not invest because they don't see a return on that investment. So the government could require them to do it. So that's one way. Of course, that requires the government to force natural gas producers to spend money, and they don't want to do it. So they leaned on the government to not effectively force them to harden the grid. And the government acquiesced because the government, as I said, in Texas, seems to be a wholly owned subsidiary of the fossil fuel industry. So what happened? What happened was
it's quite the accusation, though.
Well, I mean, look at the data. We'll
have to dig that one out.
Yeah, I mean, well, what's the accusation that they didn't move because of the payoffs?
Potentially, I mean, it's an accusation.
I mean, I took a slide out. Go to slide 35. So it's so out in the open. So Kelsey Warren is a big natural gas producer. And right after the freeze, he gave Greg Abbott $1 million campaign donation for his reelection campaign. And, sure enough, Abbott didn't, push for regulations. And again, I don't know what's going on in Abbott's head, but it certainly looks bad.
Okay, that's fair.
And so, you can draw your own conclusion, but for me, the data fit the hypothesis.
Yeah, okay. So with regards to the work that should be done, before we go into like the detail, in Australia, I think they just had a general election, right? And a new party came in, and I think one of their leading points they were campaigning on was becoming a more environmentally friendly country and more environmentally friendly policies. And then someone critical of it posted up a chart, and they compared the emissions, carbon emissions of Australia to China. And it was the accusation, well, what is the point of investing in all this change in Australia when it's going to have little impact compared to the amount that China is investing in, still building masses of coal plants and their emissions? How do you answer that? Because the climate is a global issue, but it requires some kind of unity with regards to this and policy change with regards to this. And those who act latest benefit most economically in some ways.
Yeah, I would actually say that that's not the case. China has benefited tremendously by essentially monopolizing the world's production of solar panels. 15 years ago, I testified for the Texas House. I said, Texas should become a leader in renewable energy, or we can buy from China and Europe. They're benefiting economically from exporting those solar panels around the world while still being guilty of a huge amount of emissions. So let's talk about China, because that's always the what people bring up.
Yeah.
So in 2014, China and the U.S. reached a bilateral agreement to reduce emissions, and that was what their Paris Agreement target was. And what they said there was they were going to increase their emissions until 2030. They'd peak in 2030, and then they would decline and go to net zero by 2050. The net zero by 2050 came a few years later. But this is not, the fact that they're still building plants, they're still increasing their emissions, this was planned all along. I mean, they have a grid and they have an energy system that is based on coal for the last few decades. You cannot turn off the switch immediately. You have to transition. They're doing an incredibly fast transition, but they are rapidly transitioning away from coal to renewables. And just to give you an idea, they are still building coal-fired power plants. People always say that, but their utilization factor is going down. Let me find that plot.
So it's not just a false promise for 2030.
No. Go to slide 22. Yeah, that's one. So this is the utilization factor of coal. So when you build a coal plant, it doesn't mean you're going to run the coal plant.
Okay.
And you can actually see here, and I can explain why this is happening in a second. You can see here that China runs their coal plants about half the time.
Okay.
And so, and it's going down. And so they're on track to beat their 2030 peaking emissions. So they are transitioning. They're not idiots.
And is this because these plants are used for at times of like high intensity, but the rest of the time
so the way the grid works, there's base load power that you run all the time, and then there's load following power. And so these coal plants are expensive. They're much more expensive than wind and solar. And so they actually act as wind falling. So you only run them when you don't have wind and solar power and other cheaper sources of power. And it's mainly wind and solar. They don't have a lot of natural gas. And essentially nobody burns oil for power anymore. And so they're still building plants. I don't 100% understand that, although I think it has a lot to do with when China has economic issues, they build stuff.
Okay.
So in the mid 2000s, they would build whole apartment complexes that nobody would ever move into.
Ghost towns.
Ghost towns, just for the economic benefit. So I think there's a lot of that going on in their construction plants because they don't need to run them. They can just run their existing plants more if they really wanted more coal power.
Okay.
But coal's on its way out. And in fact, China is building an enormous amount of renewable energy. So right now, they have about 500 gigawatts of wind and solar. Now, for scale, the U.S. on average consumes about 500 gigawatts. So they have a U.S. of renewable energy already built. They're going to add another 500 gigawatts in the next 5 years. So they're going to add another U.S. of energy. So they are cranking towards their goal because they understand the cost of fossil fuels. They understand the cost of air pollution. They understand all of these things. They still import some coal. They don't want to import anything. They want to be self-sufficient with their energy.
Okay.
So they are cranking. So anybody who says that they're not going to do anything, that's a misrepresentation of the actual reality of China.
Okay, so let's get into the detail. Let's talk about ERCOT. Let's talk about because that's the best example, right, of transition into more renewables. And actually, Texas has done very well in transition into solar. And
if you don't want to know why, it's because of government action.
It is, but I also think Texas is uniquely in a unique position that has an independent grid. It also has that variation between it can have very hot times, so it's good for solar, but it also has a lot of wind.
Yeah, so we have excellent renewable resources. But had Rick Perry, who was the governor before Greg Abbott, he built these transmission lines from West Texas to East Texas to the big cities. Had he not built those, there wouldn't be the renewable boom. And in fact, no private actor is going to do that because of the immense costs. Only the government can do that because the government can essentially do that, and then they can recover the cost on the electricity bills.
Okay.
And so that's a clear case of government action saving people money because wind and solar are cheap, and that saves, especially with the price of natural gas these days. Every day, Texans save money because of wind and solar power.
So what percent of the grid is currently renewable within the Texas grid?
In Texas, wind plus solar on an annual average are probably about 28%.
Okay, and the goal is close to 100%?
Well, I don't know if there's any official goal. The state doesn't have.
But you would ideally want to see that, wouldn't you?
Well, okay, so.
And is that possible, or do you need to have backups?
All right, so that's a great question. I really wanted to talk about this. So let's talk about how a grid works. Okay, so because this is the thing I always get. It just makes me so irritated that nobody will sort of do the research because there's been a lot of research been done in the last 20 years on how you create a grid that runs mostly on wind and solar that's still reliable and inexpensive.
We did have was it Sean Connell who was covered? So I know a little bit about this, but do it again.
Yeah, I'll do it again because I think it's useful to repeat this. So let's imagine you have a grid and it's 100% coal. I'm just making this up. And some of the coal is base load, so it runs all the time, and then some of the coal is load following. So during hot days, you turn it up. And you turn it up in the afternoon when people are consuming more, and then it goes down at night. So these are plants you're ramping. Now, let's add 10% of wind to the grid. So what does that do? Well, when the wind blows, when the wind blowing, the wind power is cheaper. And so you turn down the coal because you don't need to burn coal anymore. You're saving money. And when the wind doesn't blow, you turn up the coal. And that what counterbalances intermittency. And so the important thing here is by adding wind, you save the consumers money because the wind energy is cheaper. And you do reduce the profits of the coal plant, but society is better off. Mm-hmm. And you don't, and one of the big myths are you have to pay for reliability. You don't pay for reliability. The grid already has load following built into it. So when the wind blows, the load following plants just shut down. And when the wind doesn't blow, the load following plants crank up. So this is 10% of the power. So now let's go to 20% of the power. Same thing happens. Mm-hmm. You save money. The load following does it. You go to 30%, 40%, 50%, 60%, same thing happens. You're just saving money. And you're also adding solar in addition to wind, because wind and solar tend to be anti-correlated. They generate power at different times of day. And so by adding them, you have something which is more constant, but still intermittent. You still need the load following power of the coal, of the fossil fuel plants. So then you get to about 70%. And now things change.
Okay.
At this point, adding more wind doesn't do any, or more renewables actually doesn't give you any more value. You can't retire any more coal at that point, because you need the coal to counterbalance the intermittency. And so now,
and if you have no coal and there's no,
if it's 100%, if it's 100%, it wouldn't work. And everybody understands that. Yeah. Nobody says let's run a grid with 100% wind and solar with no sort of backs. I mean, it is theoretically possible, but you would have to overbuild so much extra power that it would be cost prohibitive. So the cheapest grid is one that's 70% wind and solar, and then 30% some kind of dispatchable power. Now, you don't want it to be coal. Okay. It could be nuclear, it could be geothermal, it could be natural gas with carbon capture. I mean, there are other options.
Something consistent and reliable.
Yeah, exactly. Something consistent that you can use to counterbalance. Mm-hmm. But you can easily produce, and this is the thing I want your listeners to understand, you can easily produce a 100% reliable grid that's mainly wind and solar, but you have to have some dispatchable power. There's dispatchable power, even nuclear, which is very expensive. It makes sense if it's only generating, say, 15% of your power.
Right.
That even at $6,000 a kilowatt, which is about how much nuclear costs now, it still makes sense to install it for 10% of your power, because you can dispatch. People think you can't dispatch nuclear. France does it all the time. You can ramp nuclear up and down. We just don't do it.
$6,000 per
kilowatt to install. That's to build a plant.
Okay. I'm trying to understand that as a comparable to any other. I need a benchmark.
So wind and solar are about 1,400.
Okay, so it's about 4 times more expensive
than wind and solar, right?
But it's cleaner in terms of,
and it's dispatchable. I mean, one of the things that the renewable derangement syndrome people have correct is you cannot compare wind and solar to nuclear directly. You have to think about the grid as a system. Mm-hmm. Okay, so it's a system, and you want to ask the question: what mix of energies do I want to put in there that gives me cheap, reliable power? And so you're not comparing solar and nuclear because they play different roles on the grid. You want to run as much solar and as much wind as possible because the marginal cost is zero. And as far as nuclear goes, that's what steps in when the intermittency kicks in. And so people have done all these calculations, and this is really well tried. So I say I'm extremely irritated when on Twitter people go, "Dude, sun doesn't shine at night. What are you going to do? Blackouts? Renewable energy is going to make an unreliable grid." I mean, it's like, read the literature. I mean, I'm sure in Bitcoin you run into people that will just tell you something that it's like, we've worked this out. We know this is not true. And so I'm sure you feel my frustration on that point.
Well, I mean, and this is one of the great things and big arguments for Bitcoin mining being part of a grid, is that you can actually overbuild the supply. You can overbuild the supply of wind and solar.
Okay, so let me explain that to your listeners. So if you have a grid that's 70% on average wind and solar, some days it's 120%.
Yeah.
Because when the conditions are great, when it's really windy and really sunny, you're going to be way overproducing. And in that case, you have to do what we call curtail the power, which means it's just wasted. Yeah. You just shut them down. But if you have somebody who can take it, that's right.
So we have this is the big thing we've been trying to, or people within our industry have been trying to get across to those who are critical of Bitcoin industry, is saying, no, we can actually support your goals. Bitcoin miners will happily set up within any grid, and they will say, we will take all of your excess energy. We will take all of it and we will buy it from you, and we can switch off like that. If you need us to turn off, we can turn off straight away and we can turn back on instantly. We're not like, so I'm pretty sure with the gas plants, there's like a process of winding down. We can be on and off at a click, and we will buy all your excess energy from you. So it's actually Bitcoin mining can actually solve climate issues.
I mean, if you then will pay a small amount for that could change that could help the economics of it. And I mean, you guys should be very in favor of renewable energy then, because to get to a 70% renewable grid, there are going to be days when in Texas there'll be 40 gigawatts of extra power. I mean, that would be on really windy, really sunny days. And then there'll be days when there's none. when the wind and the solar are maxed out and you're cranking on your nuclear and your geothermal, your dispatchable power. But the goal would be to run as much wind and solar as possible, and you have to overbuild it to get a reliable grid.
And you are a fan of nuclear?
I would not describe myself as a fan.
Okay.
I understand that a lot of people don't like nuclear. I understand that there are the obvious disadvantages of it. That said, I would rather have nuclear than climate change. So if you came to me and you said, I will support policy on climate change if you support nuclear, it's like, yeah, start doing it. And I have hope for things like small modular reactors. There are ways to potentially solve problems of proliferation, problems with waste, problems with safety. So, I am completely open to that. I'm also open to geothermal. I'm open to carbon capture. I mean, I think I am in favor of letting the market decide what kind of dispatchable power. But importantly, you have to have the government come in and determine the mix of variable and dispatchable power. So right now in Texas, just to give you an idea, anybody can hook anything up to the grid with some limitations. And because wind and solar are the cheapest power, and we should talk about that because I want to make sure your viewers see some data on that. So they don't, because wind and solar are cheapest, that's the only that's the majority of power being hooked up. And if you let the market decide, it's going to be 100% wind and solar, and then you're going to have blackouts. So the government has to step in and say, we're going to subsidize this more expensive nuclear power because it provides value to the grid that isn't reflected in the purchase price or in the dollars per kilowatt hour. So this is a place of agreement I have with a lot of the renewable skeptics that you do have to treat them differently.
Okay. Do you have a chart on the cost per?
Sure. Can you show 29? So the x-axis, the horizontal axis, is the retail price in cents per kilowatt hour. And the y-axis is what fraction of joules of energy are generated from wind and solar. And these are by state in the United States. So you have to understand what the state symbols are. But IA is Iowa. They have among the cheapest power, and they get more than half of their power from wind and solar, mainly wind. South Dakota, Kansas, Oklahoma, I'm reading down, New Mexico, North Dakota, Colorado.
What's HI?
It's Hawaii.
Oh,
so
okay.
they generate power with oil.
Okay.
That is a unique problem they have. They could be getting a lot of solar. I don't know why they don't have more solar in Hawaii, but so you can see that there's no correlation here between the price of power and the fraction of renewable energy. So people often will say, well, renewables make energy expensive, and they don't do that. Let me show you another.
What about reliability?
Go to the next slide.
I'm going to say, have any of these other states have any reliability issues? So
this is basically the same plot. And I should say, I made the previous one. I did not make this one, but I think it's correct because I was able to reproduce a bunch of the other plots you made. I just didn't make this one. It shows on the x-axis the duration of hours of interruption. And this is 2020, not 2021, because in 2021, Texas would be off the chart. Yeah. You wouldn't even be able to see the other states. This is how many power outages they have. And the y-axis is the percentage of wind and solar. And again, there's really no correlation here. It turns out that most power outages are not caused by generators, they're caused by transmission. A tree hits a power line, or Texas, you have an ice storm. That actually was related. Actually, Texas is bad. That was related to generators. But in most other cases, power outages are not related to generators. They're related to the transmission. So this shows that in practice, there's no increase in price with increase in penetration. But let me just show you one more.
That's increase in price to consumer?
Yeah, this is the retail price.
Okay, how much of this is subsidized?
Well, that's a great question. So let's go to slide 16. It's either 60 or 17. I'll be able to tell. Yep. All right, so this is a quantity called the levelized cost of energy. So essentially, it's the present value of the cost you're going to have to pay per kilowatt hour, per megawatt hour of power you generate. So it's how much it costs for you. So like a wind turbine, you build a wind turbine, it's going to cost you over 30 years. The present value of that is, $30 per megawatt hour. And so there are two. So you bring up a good point, which is when you say that the price is low, it's always like, well, because it's subsidized. And so the number one response is the subsidies are tiny. So if you look at this shows in the dark lines the unsubsidized cost, and in the light lines the subsidized cost. And you can see they're not very different. They're a few dollars, maybe 10 or.
Looks about 10% across most.
Yeah, maybe it's 10%. I would put it more like $10, $10 to $20 per megawatt hour.
Okay.
And so it's not a big effect. This is not what's driving it. And importantly, this is super important. Fossil fuels are subsidized out the wazoo. There are tax, at least in the U.S. There are tax breaks for drillers. They don't pay for these external costs. They don't pay for climate change. They don't pay for air pollution. These are all subsidies that they're getting, and those are enormous. And so these are actually so the subsidies actually have a very small effect. And go to the previous slide, and this actually compares all the different kinds of energy. So this is unsubsidized. So there's no subsidies on this, and it shows you the top one is top one's rooftop PV. No one looks at. But if you look at the utility scale. So the vertical axis, for everyone to see, the vertical is the different energy sources, and the x-axis, the horizontal, is the price. And if you compare solar PV and wind, they're cheaper than all the fossil fuels. And this is we've reached the point. And then if you throw on the subsidies, the price of renewable energy gets cheaper, and the price of fossil fuels gets more expensive. Or actually, I take that back. If you throw on the subsidies, it's not going to affect the renewable energy very much, but the fossil fuel energy gets much more expensive. It's heavily subsidized through these external costs and through tax breaks and things like that.
And is this generation cost, or does this include built infrastructure?
This is everything. This is the entire cost to you today to generate the energy flow of so many megawatts per hour.
But that's calculated over time. Obviously, build out requires investment up front.
So what they do here is they discount everything. So there's some upfront cost, which is not discounted. And then every year you have to pay, in the case of fossil fuels, you have to pay for fuel, you have to pay for OpEx, operating costs, and all of that gets discounted back to today. And then the energy generated also gets discounted back. And so it's this future cash flow stream discounted back today. And this is what it costs you per megawatt hour of what you're generating. And I should add, gas combined cycle looks good. It's almost competitive, but that's calculated at $3.45 per MMBTU. And the price now is $8.50.
Okay.
So
that's changed.
It is. I don't know exactly. I don't know exactly how much has changed, but it is much more expensive. In Texas, was it Rick Perry? It was somebody was saying that the Green New Deal had caused electricity prices to spike, and it's not that. It's gas prices. It's not the Green New Deal, as we said, doesn't really exist. It's gas prices have spiked because it's a commodity, and that's driving a huge increase in price.
What about the point that some people make that renewables aren't actually renewables, in that you require fossil fuels to and maybe rare earth elements to create solar panels. There's costs to build out wind infrastructure. There is a certain time limit on how useful they are, and then they have to be replaced, and that creates a lot of waste. What's your response to that?
Well, you have a bunch of points there. So let's talk about the energy required to build them. So when you build anything, you're pulling power off the grid from sort of our. And so today, our grid is largely fossil fuels. We get 60. Our electrical grid is 60% fossil fuels. So certainly, if you're building something today, it takes fossil fuels to build it. But as we transition to renewables, there's nothing fundamental about fossil fuels. What's fundamental is the energy. Once you don't need fossil fuels to make wind turbines, you need energy. Once that energy is coming from renewable sources, you won't need fossil fuels anymore. And so that I think is a really disingenuous argument. It does not apply. Certainly there are costs. You have to go build them. You need to pour a concrete pad for a wind turbine. And so those costs are all included in the levelized cost of energy. I mean, all of those costs also apply to coal-fired power plant. You've got to build those too, and they last a certain length of time. The lifetime of these things is going up. Now wind turbines last 30 or 35 years. Before they were 20 years. Certainly the waste stream is an issue. We do want to make the blades recyclable, but don't forget, we dump 40 billion tons of CO2 into the atmosphere every year. So just because you don't see it doesn't mean that's not a giant polluting waste stream. It is, not to mention all of the other pollutants that we dump. So, I mean, a lot of this is a balancing act and a trade-off. And, to me, it's quite clear that switching to renewables it's the obvious right choice. If we choose not to do that, then we're rolling the dice on the climate system. And I don't want my kids to roll the dice. I mean, I don't plan on living that long, but I do hope they live a long time. And, I think it's crazy. It's literally insane to not be transitioning from fossil fuels as fast as possible at this point.
So if everything, obviously I can't 100% confirm everything you said is correct. It'd have to, there'll be people who disagree with it, have counter arguments. But if what you're saying is correct, obviously we agree that the science is undoubtable now. The science is proven. The science is an agreement. If the cost to produce and to the energy is, as you said, is as at the price it is, and you can get the policy in place, and it reduces the reliance on a commodity prices and the variations that come with that, this reads as an absolute no-brainer.
Absolutely, I think it is.
What is the difficulty with making progress on this? What is holding progress being made? Is it lobbying? Is it different incentives for different people? Is it because there are going to be losers and there are people who are incentivized to burn fossil fuels?
Yeah, it's all of those things. Let me just say, can you show slide 15 to show? So every year, ERCOT, that's the one. Every year, ERCOT, actually every few months, they put out what they call their interconnection queue. And it tells you what people say they're going to hook up in the next year. Now, not all of this will get built, but you can see it's mainly solar and batteries. There's not that much wind, and the reason for that is the transmission lines are at capacity, so they actually can't put any more power. But because solar occurs at different times than wind, they can use the lines for solar but not wind. These West Texas, these CREZ lines, and there's a few people who are still hooking up gas, but not very much. So you are correct. The market, if for anybody who doesn't believe the numbers I showed you, look at what the market's doing. It's building renewable power, okay? It is building renewable power. China's doing it. Texas is doing it. These people who are doing this are not environmentalists. They don't wear Birkenstocks. They don't drive a Prius. They drive a Ford F-150, and they're there to make money. And solar and wind and batteries are the way to make money. So the market is moving. So why is the market not moving faster? And the answer is it's a lot of things. It's part of the culture war that we talked about. It's the fact that fossil fuels are a $8 trillion a year business worldwide. They're not going to take this sitting down, much like the tobacco companies didn't. They're going to fight for their profits, and they are doing that. They're paying off their elected representatiors, giving their so they can stay in power, and in return, those people make it nice for fossil fuels. So as an example, I have a slide, but I won't go to it. In Texas, for example, they have legislated laws to keep cities from banning new natural gas hookups. So there are cities that wanted to not allow natural gas to be hooked up in new construction, and Texas State just said no, you can't do that. And there are cities in Texas that wanted to ban fracking, and the state government said no, you can't do that. So my concern is that through this culture war, renewable energy being part of the culture war, plus the immense power of fossil fuel interests, that there will be communities and states that will simply stop. There needs, again, your listeners may not like this, there needs to be investment by the government to build transmission lines. One of the ways you generate a very reliable grid is you build in the ability to move power, to move power from one spot to another spot. So you're overproducing in Iowa, you're underproducing in Texas, we're just gonna wheel the power down there. And you need transmission lines, and you need a lot of new infrastructure to do this. And so really only the government is going to come in and make that kind of, it's like the highway system.
Well, there is an infrastructure bill. They did print $2 trillion more for that. I mean,
Yeah,
I wonder if they accounted for some of that in there.
I don't know the answer to that, but so once you have the infrastructure bill, then you run into all this NIMBYism. I don't know if your listeners know NIMBY. So NIMBY, NIMBY, not in my backyard.
Yes.
So there are lots of people who might theoretically support, a transmission line as long as they don't have to see it, as long as it's not in there. And so it becomes this. China doesn't have to worry about that. They just build the line and they bulldoze the houses that are in the way. And, if someone doesn't like it, they can. Yeah, exactly. So they have an advantage in a problem. Well, I don't know if I'd call it advantage. They have a solution that may not be good socially, but they can get the transmission lines built. Whereas we have to fight those battles. And so those are the kinds of things I worry about. So if we don't solve the problem, it's probably going to be something like that. Because otherwise, everything else is kind of pushing us in this direction. The economics certainly are. And let me just say, even if you don't believe today wind and solar are as cheap as fossil fuels, look at the trend. Solar's dropped 90% in 10 years. Wind has dropped 70% in 10 years. That innovation is going to continue. And so even if it's not today, in the next few years, very soon, it's going to be, everybody's going to understand it's the cheapest power. Except the real diehard renewable skeptics.
We talked about, I'm just going back on one point. We talked about commodity prices changing and that impacts the cost of energy. And we've talked about that marginal cost of renewables is essentially zero.
Yeah.
Am I right in understanding that's not essentially true for solar panels because they were produced predominantly in China? There's been changes in the production issues there. And if there's logistics issues, that might affect it. Are there people producing them, these solar panels here in the US domestically? And is it considerably more expensive? Do we know anything about that? Because whilst you don't want to rely on the variable commodity prices, we've seen logistics issues. We've seen issues with moving things around the planet.
Right. So just to be clear, when I say the marginal cost, that's the cost of one additional unit.
Yeah.
So once you have the solar panel, producing an additional joule of energy is zero.
From that, yeah.
So, but certainly there are costs to building the solar panel.
Yeah.
And you do have to look at that. And so, you bring up solar supply chain issues. And I think that is a good one and one that you have to think about. And I think the supply chain issues is not just a renewable energy problem. Supply chain issues affect everything. Your iPhone, the clothes you're wearing. There are people being exploited to make all of these products. And a lot of that is why they're cheap. We offshored it to China because we want cheap shit. And if we want to, we can build it here in the US, but you have to pay more. And so I think that we have to sort of face up to the supply chain, sort of the supply chain exploitation issue. And I would also say that, fossil fuels have real supply chain issues. Look at the war in the Ukraine. That's an issue. We invaded 2 countries in the last 30 years. The US did. In the last 30 years to protect the oil supply chain, Kuwait and Iraq. There are serious disadvantages to the oil supply chain, to the fossil fuel supply chain.
Not many people really want to admit that.
Well,
it's kind of obvious.
The invasion of Kuwait was 100% for oil. Nobody would even. That's the 1992.
Well, wasn't that after Saddam Hussein had invaded Iraq?
But that's right.
There were credible accusations that Kuwait was side drilling into Iraqi oil fields.
Well, look, I don't know. I'm not going to get into that argument other than to say we did it to protect the supply chain.
Yeah.
And in the 2003 invasion, weapons of mass destruction.
I think we all know.
Yeah. I'll let people make their own decision. But I think certainly if that had been somewhere else, we may not have invested the trillions of dollars that we did to protect fossil fuels.
Well, that happened at a time when Saddam Hussein wanted to move Iraq onto a petro-euro, away from a petrodollar. And also, once the invasion was complete, there's a really good BBC 4-part documentary it's worth seeing, that the military immediately went to protect the Ministry of Oil in Iraq.
Yeah.
So, we see those things. So, I understand it. They understand this. Yeah.
Now so supply chain is an issue for everything. And I do think you have to think carefully about it. And particularly, you have to look. What concerns me about the supply chain is that China is really moving aggressively to lock up the supplies of some of the minerals that we need. And so that to me is the most worrying thing, that they Biden has to go to Saudi Arabia now, hat in hand, for oil production. What happens when we need cobalt from Central Africa? And so I think that, there is a lot of innovation that's going on in the energy space, and you can already see it in like Tesla has changed their battery chemistry a little bit to avoid some supply chain issues. So I think that, the libertarian people should believe in the power of the market to innovate. If something gets very expensive, people will substitute for it. People will either find new sources, they'll recycle old sources. And I think you see battery recycling already starting. So I don't think that's going to be a big issue, but I do think that it's something we have to think about.
Danny, is there anything you wanted to ask?
No, I mean, I think you guys have covered a lot there.
Yeah, Jeremy, is there anything you wanted to ask? Is there anything I've not asked you wish I had?
Let me see. I think we got through most of it. Yeah, I think that's it. I think it's been a great interview.
Yeah, very useful. I'm going to be very interested to see the comments, and I expect to hear from Alex Epstein. I think he's going to say, can I come back on? And probably want to get the two of you in the room. But I think we're done with this for now. I do would want you and encourage you at some point to have a look into the Bitcoin mining, how this actually supports this, because I actually think some people on the climate side are concerned about Bitcoin mining. They don't actually realize the benefit it can bring. That isn't that there are Bitcoin miners who are using fossil fuels for mining, because they buy energy from the grid, and parts of the grid do come from that. I accept that, but there are very solid arguments to how Bitcoin mining can actually lead to investment in build out of green infrastructure. We actually made a show with a guy called Troy Cross. We'll send you the link that you should have to do it. And then next time I'm back in Texas, they have a meetup in Houston. And a lot of oil and gas people are going to these meetups because they're starting to invest in Bitcoin mining. I would encourage you with an open mind to go and see that, because for us, we think that's also an important part of the discussion.
All right, good. No, I think all options are on the table in my book, as long as we figure out a way to reduce our carbon emissions as quickly as possible.
Fantastic. Okay, if people want to find out more information, where would you like them to go?
Follow me on Twitter.
Okay.
I don't have a SoundCloud or I'm not hawking a book.
Okay.
Just at Andrew Dessler.
Okay, we'll put that in the show notes. And look, I appreciate you coming in to do this. It's fascinating. Learned a lot. So thank you very much.
Thank you. I think it's a great conversation.
Thank you.